Welcome to the Country Education Partnership Free Professional Development Autumn Series. My name is Tess Kelly, and I know that Brendan is your usual host, but I'll really try my best to fill his shoes. The Country Education Partnership acknowledges the traditional owners of country throughout Australia and recognises a continuing connection to land, water and community. We pay our respects to the Aboriginal and Torres Strait Islander cultures and to elders past and present. Today is session 3 of our 2025 Autumn Series, and this is our special session led by the Mathematical Association of Victoria, and it's focusing on strengthening numeracy and mathematics in middle years education. I'm going to hand to Mark McClay, the CEO of the Country Education Partnership, to give us a bit of an update and to maybe talk about upcoming activities with New Zealand people.
Thank you, Tess. Yes, CEP are very excited, depending on when you're watching this, but it is Wednesday, 26th of March right now. So tomorrow night, we have our rural education dinner and followed by the forum on Friday in Melbourne. So it's our big event. Part of that is we have visitors from the New Zealand Rural Leaders Association who are both touring the northeast of Victoria this week, but also speaking at a forum. So we're really excited that cross opportunity. We got an early question.
Great. Thank you, Mark. What I might do now is hand over to our guest speaker, who's here to chat with us from the Mathematical Association of Victoria. Her name is Leonie Anstey, and she's passionate about all things leadership, mathematics and numeracy education. Leonie's worked extensively with school districts, systems, individual schools to enable all educators to make progress to meet their mathematics education goals. She currently holds a Masters of Education in research based on the skills and knowledge for mathematics teacher coaching. Leonie's been a former principal in Victoria and around Australia and worked extensively as a teacher principal coach. Her teaching background includes senior secondary, middle years and primary, and she's also supported early childhood settings as well. So we will have a survey that will be sent out towards the conclusion of this session, so please take the time to fill that in. It helps us plan future professional learning opportunities, and also Leonie's happy to answer a few questions. So if you do have any questions, pop them in the chat as we go or hold them until the end, and we will get to them when Leonie finishes her presentation. Leonie, over to you.
Thank you, and good afternoon. Hopefully, I'm just checking that I've got the share screen happening. Thank you. And it's a really huge delight to be with CEP. And I was explaining to the team as I came on board that one of my first leadership journeys was working in a small school in South Gippsland, and had that privilege and honour of working with the team and also with some of the student programs. So it's kind of like, feels a little bit like a homecoming. So in this idea, in this next sort of 40 minutes or so, this idea of numeracy and mathematics, what that might mean in the rural and country setting, and then what it means more broadly as we're seeing this mathematics landscape altering and changing, and some of the work coming through. During the session, please do use the chat function. Happy to answer them. Sometimes I'll hold them until there's a bit of a break, but feel free. The more interaction as we go through, the better. And there will be prompts to try and get us engaged, because one of my core beliefs is we learn to do the work by doing the work and not always just listening to it. So we'll attempt to do that. So in this idea of mathematics, and just before I do start, just to follow on from the acknowledgement of country, here at MAV, we're on the land of the Wurundjeri people, and pay my respects to elders past, present, and anyone joining our call today. We at the Math Association, you can see here the eel trap, which is very significant mathematically, and of some of those First Nations people as the first mathematicians of these lands, and all our lands, of the navigational songlines and inventions such as the eel traps and boomerangs. They're our first teachers of mathematics who continue to teach us by connecting with and respecting and caring for people and country. Just a little bit about the Maths Association, just to, when people are looking to connect. this is sort of a lot of the things that we do as well as supporting organisations. And upcoming, just to keep in mind, there is some conferences. We've just been up in Shepparton. We were at Ballarat last week. We're heading to Colac in a few months' time to really support our rural colleagues and regional colleagues. We do have a MAV community. Encourage you as part of a membership that you can join that and continue those conversations. This will come in the slide deck that comes through, so I did leave this in there, QR codes. It's one of the things we do have our academics also join into. For any VCE teachers, we do have a revision program. As we say, we recently brought out some of our chief examiners out to Shepparton, out to Ballarat, so that teachers could connect. And some of those we had, like in specialist maths, for example, 5 teachers sitting around with a chief examiner. So really trying to bridge some of these supports. The other thing I'd really like to highlight as we move into this is often people talk about content knowledge, particularly at the levels from 7 to 10. And so knowing what that content is, you've got students at different levels. We've just recently starting to launch what we call Build Me Up. And it's really the content specific areas of mathematics. So teachers can watch this on demand. It's been funded to try and help secondary teachers or teachers in multi-age groupings. You're in primary setting, your kids and they're operating at level 8, you need to build up your own content. We've got some of the experts and you can see some of the images from here. In-school consulting, I'll get into the presentation. I often like to start with this bit of an image. Please feel free to use the chat. What do you notice in this image? And then if we were in together, we'd say, what are you wondering about? And I'm wondering if Mark or Tess or Maddie, what do you notice here? So some of the things that we see, and I'm just trying to get access to the chat. So some of the things that often when you look at it go, all right, well, what might this be about? And in some ways, this is a way of introducing myself and saying that over the last 4 years, all of these places actually are where I've been able to work with schools and communities and say, this is kind of a bit about me. And when I did in Google Maps, by the way, I couldn't take the star off Melbourne, not sure why, but it is currently where I am living. So these are all places where you look as far, and some of it is chopped off, but working in and around Lake Cargelligo in New South Wales, out in the Wimmera, different places around those things where it's sort of a bit about what do we notice, what do we wonder, the heart of numeracy. One of the things that I always, and I think this is really touching for me as a mathematics educator, that we judge ourselves by our intentions and others by their behaviours. And what's interesting for me around that is what are the actions that we do in numeracy education that help our students to see our intent. So we often talk about the students being connected to their world, connected to mathematics. And yet then sometimes we see people standing up and talking to students or telling them how it is. But actually often our intent is to create lifelong learning. And so sometimes when we look at this, I like to have this as a bit of a mental model to go, what are the actions we're choosing to teach in the classroom in terms of mathematics education to enable and to create some of that numeracy outcomes that we're really looking for the students for their future. So one of the things most recently when I've been talking with a colleague was to say when we're looking at what's currently happening, that it's the mathematics that we want for students and their future, not for us and our past. So what does it look like for students that are living and at school in 2025? And what does that mean for them moving forward? So here's a first image to get us thinking, and I'm going to ask you, for the people on the call, to enter into the chat which one of the following images depict your understanding of the relationship between numeracy and mathematics. You can just type a number into the chat would be awesome. And I'm not seeing anything, so I don't know if people... So Tessa said 3. So often when we look at it, so we can see Tessa, I'm wondering if you're happy to share why you've said 3.
Because they do, my understanding, or the way that I work with it, is that they do overlap each other and sort of depend on each other and sort of swap between each other.
Okay. Astra, you've said 4. Would you like to share your thinking?
Hi, can you hear me?
I can.
Oh, sorry, I'm getting used to WebEx again. I said 4 because I decided that it was either 4 or 5, but then I thought numeracy is kind of like at the core, and then you build the mathematical concepts based on more concrete understandings that you start off with and that amplify your understanding, at least at secondary. So you need to have some sort of grasp of basic numeracy before you can really go to the abstractions of the algebra that we so rely on in secondary.
Okay, so you're sort of seeing mathematics and then the core of this as being numeracy in that edge.
Well, okay, so there's some research recently about like the difference between the numbers 1, 2, and 3 and everything else. And so, those core concepts of 1, 2, and 3 obviously inform your greater numerical concepts, and then you move on to like mathematics and the colossus that algebra is, and that enables you to build your understanding into the higher mathematics.
Yeah, so there's sort of some ideas there that we see that, and if I go back to 3, so often people will say, well, it's definitely not 1. They're not related. The second one, numeracy and mathematics, sometimes people say they select 2, because sometimes in the literature we see people interchanging these words. I'm not going to say they're not synonymous. So that one of the things we know is it's not 1 and 2. In terms of 3, sometimes the questions I would pose back if we're in a larger forum and had more time to say, can you think of an example where it is numeracy and not mathematics, or mathematics and it's not numeracy? And so sometimes it's like, because it's when we've got these things separate, to go, well, where could it be? Where might it be? We often do see people, depending on the way they explain it, land on 4 or 5, as Astra was starting to share. So this idea that mathematics is the discipline and numeracy, sometimes we can talk about, is how it's enacted. And some people see numeracy is broader. It's what's happening in every discipline, and mathematics is what enables you to be able to apply it. So often what we hear is it's 4 or 5, depending on, it can be both, can be either, depending on your definition. And in fact, in reasoning and justification, we see this in mathematics. How are we reasoning? How are we justifying? So in terms of these images, there's some key things that really come up. The first one, notice I said, which one do you think and why do you say that? So what makes us say that? So one of the things we want to look at is what do we know about from the research? Sometimes we can then say, and this again in the recording when people are going back, is to say, what have you heard from others and what have you now read that might influence your thinking further? What else might you want to learn about and where might you find that? So some of the things that we can look at, so Marilyn Goose is sort of really looked at this idea of numeracy. And in fact, I've put the link and we'll be able to share that. That one of the things that we look at is to say, what is it that happens in numeracy? So I'm just copying that and dropping it into the chat. Didn't work, I'll drop. So one of the things we can look at is to say, it's all of these elements. So mathematics is the discipline, and numeracy we can look at, well, it's about citizenship. What do I need to do to be an informed citizen? What is my personal and social interaction? What are the contexts that mathematics happens in? What do I need for my work? What do I need in terms of that? And in order to do it, we can see this idea of the dispositions. We need to have some tools, some representations, and we also need to have our mathematical knowledge. So when we look at numeracy, it's much broader than the study of mathematics, but we notice that mathematical knowledge is in fact what helps us to get here. So as a summary, and again, there's a lot of words on this, which generally it's so that when it's looked at as a recording. In Victoria, in Victorian schools, what we talk about, and we see this as similar wording in the Australian curriculum, it's these four things. So recognising and understanding mathematics in the world, the dispositions and capabilities, being numerate, requiring you to use mathematics beyond the classroom. One of the simple stories I often say when using this one is to say sometimes when you think about context, I can be numerate in one context but not in another. For example, with money. In Australia, absolutely. If I go into somewhere and I've got coins and notes, if I've given a price, I can actually normally do that very fluently, easily, with understanding. I can remember the first time I went to the United States and I walked up and I was buying something for a stall and I knew I had enough money. I'd counted it out in the hotel room. I knew what I had. And yet when I went into that, I was under pressure. I was buying a bag and I knew I had enough and all I did was hand it over. I'm like, take what you need. Because in that context with those coins, I didn't have numeracy. I couldn't apply it in that context. The other one that I've had is when I had some friends over from the UK and we're playing a round of golf. And they said, how far is it to the pin? And I looked at it and I said, it says there 120 metres. But for them, distances were in yards. So actually being able to put that into context. So some of those things really do come into play here. So as a summary, numeracy is proficiency in doing mathematics. But numeracy is a social practice. So it's what we need to do to be able to interact. So when we look at our programs, mathematics needs to be numeracy rich. But actually all subjects need to be built into some of these ideas of numeracy. And so one of the things, particularly for maths leaders often grapple with, is that it is the subject specific that need to know what is the mathematics that's required and therefore how do they teach it. We might support that as mathematics teachers, but it's the job of the discipline and how it's enabled. We're going to have a couple of examples of that. So when we talk about what is numeracy, some of these things. So recently I've got quite into using recipe tin eats. I'm not sure about other people, but, this idea of, being able to understand and estimate. Really like this, like I've got to be able to do the scaling. By the way, it's interesting when you download these and if you haven't got it in the right form, when you do a scaling, it doesn't scale everything if you're not using the right conversion. So if I've moved this and I've just put TSP, but I haven't left a space, it doesn't convert that. And so students being able to recognise that as a numeracy skill. Obviously, you're being able to work out where you need to be on what day. Some of these things, calendars. So some of these things are pretty general. So all of these things are required for adults and, as we know, to be numerate. But here's one that I picked up because often I know that I've been in things where I say, well, what about in other subject areas? So this is the Year 9 reading test from a number of years ago now. And I just looked at this and I thought there's a lot of mathematics I need to do to be able to do well in being able to perform in reading. So some of the things I've got to be able to look at this and say, okay, this scale, this axis is measuring the amount of caffeine in milligrams, but actually that's different to this scale, which is measuring in millilitres. And also, interestingly, I don't know if they published this or not, but I was drawn to this, 40 milligrams, but it actually reads 50. From a mathematics point of view, that was something I noticed. I also noticed that when I'm making a comparison, these are not equivalent. So in order to answer questions fully, I've got to be able to say, well, that's saying 500 millilitres, and this one's saying 350. So this is not, if this wasn't a plus symbol, this is not 4 times as many, because actually this comes into account. And actually for students to be able to create an argument and be able to get their point across, in terms of numeracy, there's a lot of demand in this one. And even reading this, that this is 160 milligrams plus. So what does that mean in mathematics? Plus what? And some students will go, plus what? They're not plus it. Well, why are we plussing mg? And so some of the things for the teachers of English, they need to have numeracy rich curriculum in order for students to be able to do this. A second example in this one actually comes from another one, and I remember this happening. It probably tells you about some things, but actually there's two things I wanted to put in here. For students to be able to comprehend and make inference, so I've actually taken out all the mathematics terms and now this text makes no sense. So when we actually see and go through some of these things, when we take out the mathematics, I can't make sense of it anymore. Mathematically, these students then also had to interpret a scale and a legend, and one that would not normally be seen. So we can see here that this thinner line means there was less movement of currents of these plastic. So what this context was, sorry, I can see a whole lot of you on what on earth is she talking about. There was this container that fell off a boat and it had plastic toy ducks in it that then floated around on the currents in the world. It's quite fascinating from a science point of view. But this tracking, so for students to do well on this test, they had to interpret like, well, actually there was a lot here and then some here, and what might that mean? So the reason why I've used those examples is sometimes we get into discussions about whose work is numeracy. Actually, it's the work of all educators, because to understand and comprehend your subject areas. So these are the two from English. This is the latest one. I was thinking with the cyclone or ex-cyclone, Alfred. There was so much in the media, and we see media really high in the mathematics new curriculum 2.0. The use of media in mathematics is actually part of the content descriptions in secondary particularly. So with this event happening, what do students need to understand mathematically to make some decisions? So they had this whole idea, sorry, just go back, around 2 centimetres more would mean that you're at a flood level. Well, what does that mean in terms of volume of water? And what would the rainfall need to be? So if I'm teaching in secondary, actually looking at some of these events really come up. And in fact, for our geography teachers, we see this in the level 6 curriculum. So ex-cyclone Alfred, all of that data, we see this, collect, organise information, including, could be, identify locations, spatial elements, and they had bushfires in the elaboration. But they just mean that as an example. Could be the cyclone. And in fact, one of the suggestions they had is that students in level 6, so grade 6, can make comparisons to compare and contrast satellite images to show the effects of bushfires. So one of the things, looking at what mathematics would they need to do that? And I'm looking at this going, there's a whole lot of ratio and fractions taking place right there. So in order for this to be successful, we really see that we need to have some of this kicking in. I'm just going to pause there for a moment because it's already putting a fair bit of information. See if there's any questions. So some of the things I like to put in here and have that pause is, what are the possibilities for your school curriculum? This idea of what are the opportunities when we've got students that are, sometimes when we want to make the curriculum even richer. Sometimes we can elevate some of the mathematics curriculum to strengthen some of those other subject areas. And what's interesting in this comparison of curriculum, we can't assume that the level 6 mathematics has taken place in order for the geography curriculum to take place. Sometimes it's before and after. So actually looking at it and thinking, what mathematics is here so I can actually strengthen that. And if I'm a teacher not teaching in a mathematics class, where might I teach or sequence my curriculum for students to feel more successful in other subject areas in their education? And I think that's part of some of those possibilities for future learning. Just wanted to put up this again for the slides that we do see the learning progressions around numeracy. So our numeracy learning progressions, of course, linked to the Victorian curriculum, talk about that development. So sometimes having them on the side, particularly when I'm looking at other subject disciplines, can really go, there's a way that I can see this development taking place. So the VCAA have amazing resources around this one, just to build some of that numeracy learning progression. And won't have all the mathematics in there, because as Astra was sharing with us earlier in the session, that sometimes there's more in the mathematics curriculum than what we see that is required for numeracy at that point in time. And that's why they are quite different. One of the things I wanted to put as we move into strategies, all strategies in the classroom, to me, come back to this image. Came from the original work from Patrick Griffin around make, say, write, do. We saw that in his frameworks about students making connections with mathematics ideas. So how do they connect fractions with the spatial drawing of bushfires? What mental images do they do to link the symbolic and the visual with the language? So often what we see is an over-reliance on symbolic in secondary, or actually even in primary as we come up through. And in fact, we see that students who do well in VCE can interpret and verify solutions using visuals. And in fact, most recently, I was sitting in a session with one of them, the assessors for specialist maths. And over again, I heard if they'd just drawn an image of this distribution or of this thing, they would have been able to simply answer this one. Esther, I'm going to pick up that question just as we come into there, but graphing absolutely is a visual representation. And so we can see that it is both a numeracy skill and a mathematics skill. So we could see that from that image, interpreting the graph, being able to create a graph, a legend, all of those things. And we can see that for students, what are their experiences? So what draws their attention to these key points? And so sometimes we have to say, in a graphical situation, these are all the things that we need to be able to pick up. So evidence of learning. So one of the things we look at, we see this being thrown around a lot at the moment, but for me and our work in mathematics education, what are the students' evidence of learning? How do teachers know that students are making progress? And so some of the ways, and again, working with students in classrooms where this has been shared with them, I can see that you're saying mathematics, or you've been able to record this symbolically. What would be the technical mathematics language you're using right now? Congruence, that's right, that means exactly the same. So that we can actually be looking at and pressing our students for evidence that they're using these evidence of learning in their classroom. And so sometimes for me, this is the framework or a strategy to really start to embed this right in mathematics. And so what are you using here? How are you applying this to the context? I'm going to give you a chance again. You can go A, B, and C, or Ari, Min, and Joe. So students, this is just a reasoning prompt, and again, a strategy for engaging. You can put in, and I'll show you where these are sourced from. This one's a little bit interesting in that the way we created this one was 23,045, what were the characters thinking? And so one of the things that really, the reason this one's designed, because I don't know how many of you are going, I can't see the right answer. In fact, it's not there. So one of the things for students, what we see with this one is when you don't actually have the correct response, they've got to say, what are the characters thinking and what do they need to be able to do? The reason we see this as an increase in learning and reasoning constructs is that students aren't going, well, I've got the right answer, I don't care what anyone else thinks. So actually sometimes of not having the correct answer in a multiple choice, and because it's not saying who's right, it's saying what are they thinking. So we can see this one, they're just saying 23 and 45. They're not paying attention to the thousands place value. We can see this one, 23,000, I write that, and then I write 45. And the last one, we generally see this, and again, you'll see it in all the questions, 23, 45. I know it's got to have thousands, so I'll just put a 0 as a placeholder. It doesn't matter where it goes. When we've used this in a classroom with students, them actually going, so them identifying what this is doing, so therefore giving advice. If they've got that misconception, it actually reduces mathematics anxiety, because actually go, oh, well, I was thinking that, but now I'm going to give that advice that they're not doing that. They feel safe. So using a reasoning and justification where they're justifying themselves, convincing themselves and others in a number of different ways. So that's one. This one we've done in a classroom as a warm-up or an extension or an exit ticket. What questions could you design where each character would actually get it right? Because we actually see that as a misconception when students, it's called an illusion of mastery, where they get a question right, but they've actually got a misconception. So we can actually have some of this kick in. So reasoning cartoons. So here's another one. Give you a chance. By the way, there is a correct answer on this one. Just give you a moment to have a read of that. So again, using the same strategy, we can say, who do you think's right and why? However, what we've actually seen, particularly for students understanding multiple choice questioning, is actually say, what is each one thinking? Now, which one do you agree with? Because what we do see is students rushing. So actually they look at that and go, oh, well, what is Blue thinking? Oh, Blue's thinking just 6 times the number of times they went, but didn't. And so that's what he's thinking about. What's Brown thinking? Brown's looked at the 56 and then gone the number of times. What about green? What about purple? So when we do this, the students they get to learn the process, if you like, or a strategy to make an informed decision. So again, that idea of numeracy, this is absolutely a mathematics problem. It's in a numeracy context. But to answer this well, it is not about being able to read the words, most of those that are readable, but it's actually about being able to make an informed decision. A couple of teachers I've been working with in a school in a secondary context have said this has been a bit of a game changer around exam preparation because it actually slows it down to go, why have these items been designed in this way? So again, just a way of looking at a reasoning cartoon. I do use colour, and this comes from the work of Dr. Jill Brown from Deakin, is that it's really easy. Sometimes when we use names, if I put Mark, Maddie, Tess, and Kate here, all of a sudden you go, oh, well, I've got a connection with Mark and I think he's normally right, so I'll go with him. But actually what we find is when we go colour, we actually remove that as a strategy because I can agree and disagree with colours. I don't mind about that. And so again, you're deliberately taking that social construct in a way that feels safe. Again, a way to drop some mathematics anxiety. The dialogue prompts here, if I was in a classroom, who do you agree with? How could you convince the others of their characters? And what questions could these characters actually answer? So again, getting students to see this one, they're single step, and these need a multi-step. And also the character that got it correct, what would be their challenge? What question would you ask them next? Getting students to prompt these is a way of putting in extending prompts. Where were the sources? By the way, here it came from, happened to be again, great source of questions. They're all thought through and they've all got the misconceptions tacked in. So as teachers, we've got that as a resource. There's thousands of questions of multiple choice that we can call on. PISA, TIMS, all of these. So here's one that I've been using a little bit recently. So we can sometimes start with a knowledge prompt. Read that one there. Be interested, and again, feel free to put in the chat or not, but I will talk you through what I'm hearing. Ari thinks this is an odd number. Do you agree or disagree? And why? Just give you a moment to write something in the chat. Okay, so Tess is saying odd numbers need to be whole, so you disagree. What about -4? What about -3? Caroline said disagree. And reasoning? So here's some of the things that I hear when, if we're in a large group. Some people say, this isn't with adults who have been doing, that I agree because it ends in a 1. I disagree because a 4 is in the 1's place. When I hear those two things, I'm hearing the misconception and it's the way that we've been taught, that odd numbers end in 1, 3, 5, 7, 9, and even numbers end in 2, 4, 6, 8. It's a misconception, procedural understanding. Because actually the first thing I want to say is, and in the new curriculum, what it's actually said, that it's a concept related to natural numbers. So natural numbers are in the curriculum. They're in Victoria, it's defined as the counting numbers, if you like. So it doesn't include 0, which is kind of nice for this definition. So it is natural numbers. So you can look at the first thing and say, well, it fails at the first gate, called it's not a natural number. But then we look at it and say, right, what is the concept of odd and even? By the way, level 4 is about divisibility. And so often when we talk, what does it mean, divisible? So sometimes, depending on people's mathematics background, they may say things like noun and verb, by the way, not right. What we're looking for is divisible means that there is no remainder. So that there is no remainder. So when we look at this, one of the things we look at is, this is then when the explicit teaching kicks in. It's a technique. This is what my learning objective would actually look like on the board. It would not be written in as a sentence. And I would use this throughout the lesson to go, oh, 34.1, is it a natural number? No, it's neither. -4, is it a natural number? No, it's not an odd or even. What about 1.2? What about 3? Yes, it's a natural number. Is it divisible by 2? No, it's odd. When we've used this with students, that then becomes what we need to teach. So the reason why I started with a reasoning prompt, and when we've had this in level 5 and level 6, or grade 5, 6, actually grade 4, 5, 6, I was recently in, when we asked this question, our year 6 students were not giving this clearly. So they needed to know. But actually this idea of divisible, so we then looked at, 2 arrays must be the same length, and came up with some ideas or some things in the classroom. So we did then the same with prime and composite, same idea. Is it a natural number? Yes. Can it make more than one array or an area? No, it's a prime number. If not, it's composite. So again, leading them through, you ask them if it's a prime or a composite. If they don't know, then we teach it. By the way, if I went into a classroom and said, is 34.1 an odd number? And they went, no, it's not a whole number. Oh, sorry, it's not an, I'd say whole number, and I might then put in an integer, negative integer. But then to make sure that we've got a full definition, then it looks like this. So if I'm talking about a strategy of how I build that in mathematics, I've left that one in there for the slide deck because we can then do the same to go, I can lead from odd and even, I could then be looking at prime and composite and connect. Remember that framework that I said about make, say, write, do. I'm connecting the idea of natural numbers with arrays, with prime and composite, with the idea of ordering factors. What we noticed what I used to notice in the secondary around year 9 and year 10 when we're doing quadratics is that students were not able to identify the factors. Generally, they were missing this idea about creating rectangles. This is what it looked like in an actual classroom. These are, I think these are grade 5 and grade 6. So these kids were going through, they were grabbing a handful of blocks, and then they had to decide and convince themselves and others about this idea of prime and composite. Because in this class we did a pre-assessment, and odd and even, prime and composite, and square numbers were not embedded, but we connected all of those. Often I'm asked is if they haven't got one, would you separate those concepts out? Absolutely not. Because actually at this level I needed to fast track odd and even. I needed to get that out of the way. I could connect it with prime and composite because we were looking at an array with the blocks that were just here. You can see this student was trying to make some square numbers, nice thing around some of those materials. Using that manipulative as a strategy, limited the numbers to about 25 because that was their handful. And then we could go through with what some of those were. So just in terms of this last part, I wanted to touch on, we were seeing a fair bit of this in the research and people tapping into this at the moment, this idea of interleaved mathematical practice, what I look at it and see it means and what it doesn't mean. So one of the things that we do see is, this is a very common question we see in the secondary, find the height of the tree. What's interesting that we find is that it's not telling you which strategy to use. Could be for Pythagoras. So a student may look at this and go, oh, I've done something with right angle triangles before. Maybe it's Pythagoras. It's got a slope. Maybe it's a gradient problem. Maybe it's an area problem. Maybe it's a similar triangle problem. This could be, I mean, often we're not finding the height of the tree. But by the way, most recently I've been trying to find the height of fences, but won't go into my life story. But when we're looking at this, student then can go, I don't know which one to use. This sometimes comes from this idea of blocked practice. It gives an illusion of mastery. So sometimes when we see, particularly in worksheets or whatever, it says, solve this using similar triangles, solve this problem using Pythagoras. And then when they're faced with a problem in a test or an exam situation, they don't do well. You get this maths anxiety, test anxiety, and they say, I can't do this anymore, but I could do it. When we did Pythagoras, I could do this, but now I can't. Or when I did similar triangles, I could, and now I can't. So one of the things that we see is this idea of offering. They definitely need to have lessons that are about learning Pythagoras, by the way, and similar triangles. I'm not saying that. But what I'm saying is once they've got that, having problems where they actually have to make decisions, what mathematics would be most efficient here? And in the primary setting, it can be about a problem such as an addition problem. So we can be looking and saying the problem might be a difference, Ari's got 47 marbles and he's lost 40 and he's lost 12. How many does he now have? The student has to think to themselves, is this an addition problem, a subtraction problem, or can I think addition? So they've got to make decisions. And actually having this all the way from primary through to secondary, we see this. How do we make sure that we don't always give them a crutch to say, solve it doing it this way? Because actually we see a descaling or a dropping in confidence in mathematics over time with that. Just going to finish off by saying we learn to do the work by doing the work, and you can see here in teacher teams that they were exploring some spatial things here. And actually what they were doing was the teachers doing this in PLCs. We actually see a strengthening across that board when we're exploring the mathematics. So that Cyclone, Alfred, teachers sitting and doing that together to say what mathematics is possible absolutely is can be very, very beneficial. Also helps to, if you've got more than one person looking at the work to go, how might we do this for students at level 1? How do we do it for students at level 5? The reason why I'm saying level is that, in many of the rural contexts, you've got students at levels rather than their data manufacture. So what does that look like? So how do we play around into that sphere? So again, improving the skills, the attitudes, the learning dispositions, and the knowledge, academically challenging content. Again, as a slide, I went through and looked at what are the critical and creative thinking demands of the new curriculum? What do we do in mathematics? And we see all of these attitudes and dispositions in the curriculum and an expectation that students have got access to that, as well as in mathematics curriculums. And again, in numeracy, how do we make sure this idea is coming up? Again, what we're seeing in senior secondary is the verification is something that students need to be developing. The show that means the working, drawings, diagrams, and we're seeing that they could actually gain marks for those by actually drawing diagrams and visualising. So just to, as my last thing, I just do want to leave with this paper that's just recently been released by AAMT. It's talking about the pedagogies of mathematics, both to be able to look at and to see what can we strengthen. If you haven't had a look at it, I definitely recommend that you do. It's something that I look at and think, oh, I can see where all the frameworks, regardless of what system or frameworks you're using in your school, that this is a way in order for us to strengthen some of those practices in our schools and our classrooms. And by my timing test, I'm right on 4:45.
Leonie, you absolutely nailed your timing perfectly. Wow, there was a lot in that and a lot of ideas that could go so many places. We did still have a question from Astra just regarding where does graphing fit into numeracy or mathematical skill. Did you want to jump back to that quickly, if you can?
Sure. So when we look at, and in fact, I might try to find a image. No, I took it out of the slide deck. That when we do see that visual, the language, and the symbolic. So absolutely, the idea of graphing. And again, one of the things that we've seen come through is that students using a ruler. Like, I was actually quite stunned, and I've heard it for 3 years in a row now, that students not gaining the marks for graphing in the Year 12 exams because they didn't use a ruler for getting that shape correct. So sometimes I look at that and think, what are we doing for students that they should be doing for themselves from very young? So sometimes we see an over-reliance on giving them the graph, actually drawing the axes and making sure and labelling them, so that when they're actually doing this in life and interpreting them, they're not making those same errors and being able to look at those. So I do think that being able to put graphical representations in as many areas of the curriculum as you can, it definitely is going to help.
Absolutely. I'm not sure that I needed the reminder that caffeine is toxic, but that was a great example that you actually used to show, it's very easy for misconceptions to come into play and affect students' ability to get the correct answer. But there was so much information. I'm just waiting to see if anyone's got any more questions, pop them in the chat. There was so much information that you gave us and many opportunities to take that further if we're interested with links to research and whatnot. Media is a huge thing, isn't it? And if you did, I would be very interested taking that back to my school to have a session with the teachers. We subscribe to Newsendemic, which is just current issues in the media that's put into context for our age students, but actually going through an article and taking out anything that is considered numeracy or numerate, what would make sense or what's left to the students to be able to comprehend. So that's a different way of looking at it. The reasoning cartoons, that was a very interesting one too, because to get the kids to think about the connection or bring the conversation down to the process, and that begins that talk about strategy selection and why they've chosen to go that way or what are the other possibilities. So many things in there for me to think about, which was great. Were there any other questions? Sorry, I'm just going back. Maddie's gone in and popped the poll there, please. So if you could click on that to give your feedback, that would be excellent. Thank you. I can't see any further questions there for you, Leonie, but people feel free to unmute and jump in if you can. Mark, did you have anything to add?
No further questions from me.
I was also very interested, Leonie, you brought back something that I had not forgotten about, but you do go through so many different professional learnings over the years. So to see just that image again of making, saying, writing and doing, that really took me back to, to some of the basics and some things that you might let go to move on to whatever the next professional learning that you do. So that was a fabulous reminder for me from back in the day.
Yeah, absolutely. And in fact, it's sometimes interesting that there's so many things that we saw make great traction. And in education, like, what can we hang on to and sort of go, all right, with new information coming in, how do I use this as a filter to make sure that we're making learning as best it can for our students for their future? And so I always look at that sometimes things can go, well, that was related to maybe our own experience in mathematics, but what about these students right now in 2025? What does it look like for them? And I'm always trying to carry that and the making, saying, writing and doing, that it really is active. It's a really lovely lens. Sometimes it's that thing sometimes reminds us to let students do the mathematics. One of the latest things we're seeing in any of the frameworks coming through is I look and go, yep, students do maths. Students do understand the maths that they need to do, and students do the maths. And they do some more maths, and they do some more maths. And so when we're looking at a maths classroom, it can sometimes be a lovely lens to say, in this hour, how much of that time did students actually have time to grapple, to be, to really grapple with ideas? So they knew what the idea was, but now how do they grapple with it? And I think that's where the joy of mathematics can come in.
Yeah. I'm wondering, can you tell us a little bit more just quickly about the Build Me Up that you mentioned right at the start of the session? I have come across, even when you're organising classing structures for the upcoming year, you'll often get the comment, oh no, but I can't teach, anything above year 8, or I really don't want to do the 5 6s. Not only are the students taller than me, but I'm not confident with the maths curriculum and don't feel that I could teach it. So is that what the Build Me Up is designed to do, to build that confidence with teachers? Or
Yeah, absolutely. So there's currently 12 modules, and it was funded through the Department of Education. So it's free to all government schools, a small cost for Catholic and independent schools, and it's on the website. And I can drop that link in. And one of the things is, so we've got some of the academics that come in and we're filming them. So just having that to go, all right, well, how would I teach fractions at level 7, fractions at level 8? We are looking to expand that further, as you say, with the grade 5 and 6 content. And so the modules are coming online and they're already there. People are accessing them, has some resources associated with them, getting some nice feedback. So absolutely. I also watch them. So sometimes it's one of those things that's like, well, I haven't taught year 9 and 10 logarithms for a long time. So actually I'm just going to watch this video to have it, come back almost, and it has that chance. There will also be some check-in sessions that we'll be advertising through MAV with drop-in sessions where people can come in and ask questions about the content.
So it's not just technically for the year level that they're teaching, also to support that differentiation for the students you're needing to extend, but the students you're needing to support as well.
Absolutely. So it is really about what is this content, like, rather than it being teaching activities. It's sort of like, to teach functions, you need to do this. To be able to teach fractions, this is what the ideas are. So it's really about teacher knowledge.
Perfect. Did anyone have any other questions or any other comments or wonderings? No, I might just, Mark, do you have any extra plugs or updates that you need to do before we wrap up?
Yeah, I was just actually reading the critical connections between numeracy and mathematics document, trying to figure out this question with lambs and sheep and horses and all sorts of things going on. So I'll continue that after we finish. Would you like me to speak about next week, Tess?
Yes, you can take that if you like. Go for it.
Excellent. I will say thank you very much to Leonie and Tess. I felt like we were eavesdropping a conversation, which was lovely. So thank you for the content, Leonie, and the work that the Maths Association Victoria does across the state. It's great that you get out to rural areas and support rural areas, because organisations who do that are fairly rare. So on behalf of all rural educators, we thank you that you do that, and thank you for today's session. Much appreciated.
Yeah, thank you. And we're off to Warwick, Nabil, the start of next term. So that's a nice travel.
Brilliant. Thank you. Yeah, I was just there a couple of days ago. Next week is the last one in our autumn series. So really excited. We have Dr. Chloe Kidd on board, and she works in the area of it's just gone from me. Child and adolescent mental health, a research fellow. So she's going to share some of her research, and we're really excited. A CP friend who comes back each year, Dr. Adam Fraser, he did a report with Dr. John Molyneux from Deakin Uni around secondary traumatic stress on school staff, and the research showing that over half experience some degree of depression, and more than a third are considering leaving the education sector altogether due to the emotional impact of secondary traumatic stress. So yeah, that'll be fascinating. The report was finalised late last year. There were 2,300 respondents. So that certainly validates the data with the number of people participating in the survey. So Adam will be just running through the results of the key sort of findings from that report. So we're really excited about next week's session with both presenters highly engaging. So we're looking forward to it. But back to you, Tess.
I think that you've ticked pretty much everything off for me. So the topic or the heading for next week's session is managing anxiety and secondary trauma in schools. So yeah, 2nd of April from 4 till 5. And obviously all sessions are recorded. So if you've missed a session that you really wanted to get to and you just couldn't, you're able to go to the CEP website and find all of the session recordings there to catch up on or to share with your staff if Wednesday night's not really fitting in with your meeting nights, then you can use the recordings to do that professional learning as well. Mark, I think, and Maddie, if you've got anything else, I think that we're done. Please fill in that poll, and I'm actually looking forward to coming down tomorrow to join in on the forum, the dinner and the catch up with our friends from New Zealand. And yeah, here's wishing everyone a great week in your rural settings.
Thank you, Tess. And Brendan's position is certainly under jeopardy after your great performance.
Yeah, I don't think so. I think Brendan will be welcomed back with open arms.
Thank you all.